Hi everyone, you're welcome to DML Physics Concepts. Kindly subscribe to this YouTube channel, like this video and share this video to your friend. And at the same time, if you have any questions, you can also drop your question in the comment section. Thank you for this class. Today we will be proceeding from where we stopped, which is on projectile motion. And during the last class, we explained the concept and the applications of the and some of the formulas that we'll be using for this class. So if you want to watch those videos, I will drop it in the description link. Just go to the description link and watch those two videos. So I've explained the concepts and all we need as far as projectile motion is concerned. For we've done video on projectile 1, projectile motion 2, and today we'll be looking at projectile motion. We'll be looking at number 3 now, and today we'll be looking at the application. We'll be solving examples using those concepts we've already learned. So let's start with example 1. But before we look into those examples, I want us to go quickly over some of the formulas we'll be applying. Now we have the vertical projection at angle theta to the horizontal, and then we have horizontal projection. We have two projections that we have discussed. Number 1, we have the one that is vertical projection. We have vertical projection at angle theta to horizontal. That's number 1. Then number 2, we have the one that we call horizontal projection. Irrespective of any type of projection it is, each of them has two independent components, which is the vertical component and horizontal component. And we have explained in previous classes that those two components, they are independent of each other. So let's look at the formula we'll be using before we now start with the example 1. Now for vertical component, for the vertical projections, the formula we'll be using as, if you are looking for time to maximum height, time to reach maximum height, the formula is what? U square is U sine theta over G. If you are looking for the total time of light, that is capital T, that is 2U sine of theta over G, that is 2 of T. Otherwise, we can write it as T equals to 2T. Because the time it takes an object to go up is also the same time it's going to take the same object. Now, what is the maximum height? Our maximum height is given as U square sine square theta over 2G. That's our maximum height. And what's our range? Our range, which is horizontal distance, is U square sine 2 theta over G. In previous classes, we have proven all this formula, how we arrive at this formula. We said these three, they are vertical component, while the range is horizontal component. And that's how we deduce the formula. Now let's look at, now all these four formulas I mentioned, they will be applied when it comes to vertical projection at angle theta to the horizontal. Now let's look at the second case, which is the horizontal projection. If it is horizontal projections, our formula for height is going to be gt square over 2. We want to look for height, like in this case. Now we want to look at the total time of light. Our t is going to be the square root of 2h over g. That's the formula I'll be using. And if I want to find the range, let me write it to this side because of the space. Our range is going to be u multiplied by t. So since our t is also the square root of 2h over g, so our range can also be written as u the square root of t, which is 2h over g. So these are the formulas we'll be applying. So for vertical projection, the formulas I write, that I put down in black, is going to be the formula we'll be applying. And when it comes to horizontal projections, the formula that I put down in red are the formulas we'll be using. So let's quickly go to example 1 now. So let's read example 1. An arrow is horizontally projected. If you look at that one, that statement suggests or is telling us now that this kind of projection is horizontal projection. Remember we said we have two projections. Projection at angle theta to the horizontal, and then we have horizontal projection. So let's now solve this question now. Now that we know that this kind of projection is horizontal projection, so let's take parameters. Remember that let's look at this illustration. When an object is projected horizontally, remember that for vertical component of this force, I want to do a quick recall. The vertical component of this force, initial velocity u is 0 when an object is falling down. But when we want to look at the horizontal component of this force, that is where u is 10 meter per second as given in the question. Is 10 meter per seconds as given in the question. So which means the question, what we are looking for, will determine whether we are going to consider the horizontal component or we are going to consider the vertical component of the force. So let's look at what we are looking for now. So we are looking for the height, and we look at the height. Height has to do with the vertical component. So since height has to do with the vertical component, then in this case, to determine the height, we are not going to use this u, this initial velocity. This initial velocity, 10 meter per second, is not what we are going to use, because the question we are looking for is the height, and the height is a vertical component of motion of this body. So in that case, our u will be taken as 0, and our time is going to be taken as 7. And since object is falling under gravity, our g is 10 meter per second square, and now we are looking for our h. So in this case, how do we find our h? Therefore, our h is going to be gt square over 2, that is half gt square. So which is equals to 10 multiplied by t square, that is 7 square. Our time is 7 square over 2. So it's going to be 10 multiplied by 7 square, that's 49. 49 over 2. So that divide this one now, is going to be 490 divided by 2. And what is 490 divided by 2? And 490 divided by 2 is 245. That is 245 meter. So the 245 meter is the height of the fall. Now what we are saying is that even if the question is rephrased and they change this velocity to 15 meter per second square, the height of fall is still 245. If they change this velocity to 15, to 20, to 30, irrespective of the velocity, the height of fall is still 240 meter, because the velocity you use to throw an object has nothing to do with the vertical component, because at horizontal movement of the velocity is constant and acceleration at this point is 0. So this body is only falling under gravity. So it is only vertical component of force, which is the gravity, that has effect on this body. So we are going to resolve this question vertically using the vertical component, and we have arrived at our answer. So that's the concept you need to understand when it comes to horizontal projection and vertical projection. There is a vertical component and there is an horizontal component of the force. So I won't take too much time in explaining the other questions or other examples. So let's look at example 2 now. So for example 2 now, a ball is projected horizontally from a height of 20 meters above the ground with an initial velocity of 0.4 meters per second. Calculate the horizontal distance moved before hitting the ground. Now, if you look at this question, it's also horizontal projection. So we know there is horizontal projection. So the next thing is we want to look at what we are looking for. Is it the question they're asking for? Is it the question that has to do with the vertical component of this horizontal projection, or the horizontal component of this horizontal projection? So let's look at the question. Calculate the horizontal distance. So the horizontal distance is the horizontal component, and since it's an horizontal component, we remember that the formula for horizontal component is our range. Our range is ut, and our range is also u, the square root of 2h over g. So those are the two formulas that we use to find our horizontal distance. So let's now pick the parameter. Remember, for horizontal distance, u is constant, so u is not 0 for horizontal movement. Remember, as I explained in the previous one, when the object is projected horizontally and you are looking at the object horizontally, the u here is not 0. It's going to have a value, but acceleration here is 0. So let's get to look at that one. Sorry for that. So let's now solve using the formula that we have on the board here. So let's pick the parameters we have. If I want to pick the parameters we have, we discover that from the parameters, our h is 20 meter. That's our h is 20 meter. The other parameters they give us, u, that is 0.4 meter per second, and now we are looking for our r. Our r is unknown. So since our r is unknown, so we use any suitable formula from the two formula that we use for horizontal components. So our R now is going to be U, and U is 0.4. Remember that we are looking at horizontal components. So for horizontal component, our U is not 0. It is when the question they give us has to do with vertical component that our U will be solved vertically, and at that point that U becomes 0. So 0.4 square root of 2 multiplied by h is 20, the height is 20, then over 10. So our R is going to be 0.4, the square root of, this one is going to be 40 over 10. So R is going to be 0.4 square root of what? Square root of 4, because this one is going 4, and the square root of 4 is 2. R is going to be 0.4 multiplied by 2, is going to be 0.8 meter. So which means our horizontal distance of this object is 0.8 meter. So the point is, you must know when to use the vertical component and you must know when to use the horizontal component. So let's look at example 3. So let's look at this example 3. An object is projected horizontally, so that is also clear. That is horizontal projection from the top of a cliff with a velocity of 7 meters per second. So let's pick the parameters as we have it. 7 meters per second, and lands on the level ground at a point 56 meters from the base of the cliff. If you look at that one, where it lands 56 meters from the base, and that is telling you that what they have given us is the horizontal distance covered, which is our R. So that is our R, which is 56 meters from the base. Now then the question is now calculate the height of the cliff edge. And you have to note that since they said we should calculate the height, you should know that what we are looking for is the vertical component. So the formula we are going to use has to do with vertical component, which is h equals to gt square over 2. That's the formula we are going to use to find our height. So there is no any other formula we need to use. This is the formula because it is a vertical component. Irrespective of the parameters we have picked, what we are looking for will determine whether we are looking for the vertical component of that projection or horizontal component of the projection. And since we are looking for height is vertical projection. So h is gt square over 2. So the next thing is we look at how we are going to fill these parameters using this data we are given. So h is what we are looking for. G is 10. Know that g is always 10 because for vertical projection g is 10 meter per second. Let's take g acceleration as 10 meter per second. What is our t? So we don't know our t. So the problem is we don't know our t. Then to get our t, what's the formula to get our t? Remember that our t is always the square root of 2h over g. If I want to use this formula for t, then I won't be able to do anything because I still don't know what h is. Then another formula we can use to find our t is also r over u. You have to recall that t is also r over u. So let's find our t from here now. So we now say okay. So let's say then our t is going to be r over u. And what's our r? 56. And what's our u? 7. So our t is going to be 56 divided by 7. That is 8 seconds. Now that we know our t, we now go back here. Why do we use this formula to find our t? Remember, whether the object is projected vertically or projected horizontally, those two components are independent of each other, but something is common between them: the time. The time this stone will use to fall is also the same time it's going to cover to still land at the same ground, whether it is vertically or horizontal direction. So that's why our t is the same thing. So in that case, then we find our height. Our height will now be 10 multiplied by our t. Our t is 8 square, then over 2. So our height is going to be 10 multiplied by 8 square is 64, then over 2. So our height is going to be 640 over 2. So what's going to find our answer for our height? If I divide both sides by 2, then our height is going to be 320 meter. So our height is 320 meter. So let's look at example 3. I mean example 4. So let's look at this example now. A stone is projected upward. If you look at that word, projected upward is talking about vertical projection. Although it's vertical projection, it will also have its horizontal component and vertical component of the motion of the projectile. So the stone is projected upward at an angle theta to the horizontal. So let's take the parameters. Our theta is 30 degrees. Now, if the initial velocity, if u is 100 meter per second, calculate the maximum height. So we are looking for the maximum height. And remember that when an object is projected vertically and at an angle theta to the horizontal, our maximum height h is given as u square sine square theta over 2g. So let's substitute that parameters. So our h is going to be u square, that is 100 square sine square theta is 30 degrees, then over 2, and let's take our g to be 10, that is 10. So our h is going to be 100 square, is like saying 100, that is 10,000, then sine square theta, that is sine square of, and theta is 0.5. Let's say sine 30 is 0.5 and square of it. Sine 30 is 0.5 and we are looking at sine square theta, so 0.5 square, then over 20. So where's our h now? Our h is going to be 10,000 multiplied by what is 0.5 square. So 0.5 square is going to give us that is 0.25. So let's just look for the final answer like that. So the final answer is 125 meter. So our maximum height is 125 meter. So let's look at the next thing now. So you can copy that as I clean this side of the board, and you can pause the video to copy if you need to copy. Then I'll move to the next thing. So the next thing is we want to look for the time to reach the maximum height. And remember that time to reach maximum height is given as t equals to u square. It's given as u sine theta over g. That is the time to reach the maximum height. And if that's the time to reach the maximum height, so let's continue from this side as I clean this side of the board. So let's now substitute now. We now say t equals to u 100 sine 30 then over g, that is 10. So that is 100 sine 30 is 0.5 then over 10. And if this one divide this one, it's going to be 10 multiplied by 0.5. Our time to reach maximum height is going to be what? It's going to be 5 seconds. So time to reach the maximum height is 5 seconds. That is number 2. Now let's look at the total time of flight. Remember that the total time of flight is 2t. That is the time to reach maximum height plus the time to fall down to the ground. And those times are equal. So the time it takes to reach maximum height is also the same time it's going to fall from the maximum height to the ground level. So in that case, we can just say t equals to 2t, or you use this formula, t equals to 2u sine theta over g. So there is no need using that formula since already we know the value for our t. So since our small t, that is the time to reach maximum height, is 5, our total time of flight is just going to be 2t. So which is 2 multiplied by 5, which is going to be 10 seconds. So the total time of flight is 10 seconds. So let's look at what is the horizontal distance. And if you look at that, horizontal distance suggests the range, that is r. Horizontal distance, and that one is u square sine 2 theta over g. So that's going to be our range. So let's solve it here. That is going to be 100 square sine 2 theta, and theta is 30, then over 10, g is 10. So we are going to have 10,000, then sine 2 theta, and 2 times 30 is 60. Sine 60, that is over 10. Let's find our range now. Our range is now going to be 10,000 multiplied by sine 60. And what is sine 60? That is 0.8660, then divided by 10. So let's just give the final answer. So our final answer, when we multiply everything and divide by 10, our answer is going to be, so the final answer is going to be 866.025 meter. So that's that about that one. So let's look at the next example. This class, I want to use this class to complete the full concept of the application of projectile, both vertical and horizontal projection. So let's look at the next example now. Okay, from these examples, we said a body is projected from the ground at an angle theta to the horizontal. So that's also vertical projection. So let's take parameters now. So in this case, theta is unknown. Our theta is unknown. Then with the velocity, initial velocity, our u is going to be 30 meter per second. It reaches the maximum height. We are given our maximum height to be 11.25 meter. Then calculate the value of theta. So to calculate the value of theta, since we are given maximum height, so to calculate the value of theta, we just say h equals to u square sine square theta over 2g. And what's our u? That is 30 square sine square of theta over 2g. And let's take our g to be 10. So after that, let's now remember that is our h, and our h already have value, that is 11.25. That's our h value. Now let's cross multiply. If I cross multiply, then it's going to be let me cross like this, that is 30 square sine square theta equals to 11.25 multiplied by 20, that is 2 times 10 is 20. Alright, let's break it down. What is 30 square? 30 square is 900. 900 multiplied by sine square theta equals to, what is 11.25 multiplied by 20? So 11.25 multiplied by 20 is that is 225. That's 225. So let's make sine square theta the subject of the formula. So sine square theta is going to be 225 over 900. So our sine square theta is going to be, what is 225 over 900? So 225 divided by 900. So that one is going to give us 0.25. So sine square theta is 0.25. So what is now, if sine square theta is 0.25, let's square root both sides. The square root of both sides will remove the square. So we now say sine theta will now be the square root of 0.25. So what's the square root of 0.25? The square root of 0.25 is going to give us 0.5. So sine theta 0.5. And what is now theta? Theta will now be sine inverse of 0.5. And sine inverse of 0.5 is going to give us 30 degrees. So from this question, our theta is determined to be 30 degrees. So it's 30. Our answer for theta is 30 degrees. Now let's look at the next question. The time taken to strike the ground. Since the body strikes the ground, so that time that we are talking about is talking about the total time of flight. So let's clean this board and solve that. The total time of flight. So our total time of flight is given as t equals to 2u sine of theta over g. So let's substitute the parameters now. 2 multiplied by u, our u is 30, sine theta, and theta is already 30 now. 30 then over 10. So our total time of flight is going to be 60 sine 30 over 10. And sine 30 is 0.5. So it's going to be 60 multiplied by 0.5 over 10. So what's going to be our t now? Our t is going to be 60 multiplied by 0.5. That's going to be 30. Then divided by 10. So our total time of flight is going to be 3 seconds. Our total time of flight is 3 seconds. So let's look at the third question. The third question is we are to find the range. So how do we find the range? Remember the formula for range. Since it's vertical projection, our range is u square sine 2 theta over g. That's the formula. The most important thing is to master the formula and know whether you are dealing with vertical component or horizontal component of that particular projection. Projection could be vertical projection or horizontal projection. And irrespective of whatever projection it is, it has vertical component and horizontal component. So our r is going to be our u square. Remember our u is now 30, is 30 square sine 2 theta, and our theta is 30 over 10. So it's going to be r is going to be u square, that is 900 sine 60, because this one is sine 60, then over 10. So our r, if I just press calculator straightforward because of our time, you can just say sine 60, whatever value it is, multiply by 900 divided by 10. Our total answer is going to give us, so our final answer is going to be 77.94 meter. So that's the total range. Now let's look at something that is very important now, the velocity 2 seconds after projection. So let me clean this and analyze that one so that we can solve. So now we have gotten our h to be 11.25, our total time to be 3 seconds, and our range to be 77.94 meter. Now let's look at our velocity 2 seconds after projection. Recall that I said something that when an object is projected like this, along the line, let's say an object is projected at angle theta to the horizontal. This one is in the previous. At every point in time, there's always a vertical component, there's always an horizontal component, and the velocity changes as it moves like that. So the direction of the velocity changes as it moves like that. So the question is that what's going to be the velocity of this object at 2 seconds after it has been projected? So when the body lifts from here, after 2 seconds, what's going to be the velocity? Remember, at starting point here, our velocity is 30 meter per second here. It's 30 meter per second here. So after it has moved 2 seconds, what's going to be our velocity? So what we are going to do to know our velocity is simple by knowing the vertical component here, horizontal component here, and find the resultant. So the resultant velocity is going to be our velocity 2 seconds after projection. So now, remember that when an object is projected, the vertical component uy, remember, is u sine theta, and the horizontal component, which is ux, is given at u cos theta. That's our vertical component, and that is our horizontal component. Now, for vertical component, we are going to look for our vy. Remember, for vertical component, we are going to use the velocity at vertical component here. We want to look for the velocity for vertical component here. So velocity here changes with gravity. You remember that it changes with gravity. So our velocity here is going to be v equals to u. Because the object is still going up, let's still take the object as whether it's going up or coming down. So we can still say minus or plus anyhow. So v equals to u, because it's going up, the object is still going up, so it's moving against gravity. So let's take a negative formula. V equals to u minus gt. V equals to u minus gt. That is the velocity we are going to use. We want to know the vertical component of force here. And for vertical component of force, velocity is changing, and velocity is changing under gravity. Why our u for vertical component is u sine of theta. So our velocity for this point I'm touching is going to be u. Our u is u sine theta minus gt. So our vy is going to be u. And what's our u? U is 30 sine 30 minus 10 multiplied by t. And they say the 2 is 2 seconds after 2 seconds. So let's see what we are going to have. Our v is going to be 30 multiplied by 0.5 minus 20. And 30 multiplied by 0.5 is going to give me 15. 15 minus 20. Good. And 15 minus 20 is going to give me minus 5 meter per second. So it means the velocity here is 5 meter per second. You see that it's reducing already. So the velocity is 5 meter per seconds. So velocity of the object 2 seconds after projection is 5 meter per seconds. So that is our velocity. Now let's look at the velocity for the horizontal component. For ux, remember for ux is u cos theta. So for that one, u is equal to u cos theta. So let's find that one. Let me clean this side so that I'll be able to see clearly. So our v for x, or let me say ux, is going to be u cos of theta. Our u is 30 and cos theta. Theta is also 30. And u cos theta, if I multiply and get cos theta, our answer is going to be 25.98 meter per second. So which means, as the object starts from here, the vertical component started from, we have a vertical component, but when the body gets here, it is changing. So this u, the horizontal component us, along this time will always be 25.98 25.98 meter per second at this point. Even when the object reaches here, and the object is already coming down, this horizontal component will still remain as 25.98 meter per second. So as the object is moving, the velocity along the horizontal component is always the same. So now that at this point, that's where we want to analyze the velocity of the object at this point. So we already know the vertical component to be -5, and we know the horizontal component to be 25. So we are going to draw, find the resultant. So to find the resultant, since this one is -5 for the y-axis, let's recall our resolution of vector. When y is negative, it does not mean that it's negative, but it's just that it's pointing towards the negative y-axis. And what's the negative y-axis? So let me clean this object now. Let me clean this one. So the negative y-axis is saying that it is pointing downward. So this one is the 5. Remember, axis is this. This is the positive y-axis. This is the negative y-axis, where this is the 0. So negative y-axis, that is the vertical, while the horizontal is towards the positive. So which means this one is for the negative. For the horizontal component, this place is 25.98. So let's find the resultant velocity. So to find the resultant velocity using our R, we use our Pythagoras theorem. If you want to recall this one, you can also go to our previous classes where I talk about resolution of vector, how to add vector. So R is now going to be the square root of 25.95 square plus 5 square. So let's find our square root now, and then our R is going to be the square root of this one is going to be 674.96, then plus 25. So our R is going to be the square root of 699.96. Then the resultant is going to be 26.46 meter per second. So the velocity of the object 2 seconds after projection is going to be 26.46 meter per second. At initial it was 30, but 2 seconds after, the velocity has reduced to 26.46 meter per second, and that's how the velocity of the object will be changing vertically. But horizontally, the velocity of the object will remain as 25.98 meter per second. Remember that when a body is projected, it has two independent components, the horizontal component and the vertical component. So let's know the direction now. What is going to be the direction of the body, the velocity of the object? So we can also look direction. The direction is always angle between the resultant and the horizontal. So we can just say tan theta. If you recall that one, tan theta is going to be the opposite, and this one is going to be the adjacent. So it's going to be opposite, that is 5, and adjacent is 25.98. So if I want to do that, let me just do it to this side now. Then tan theta is going to be, so 5 divided by 29. So that's going to give us 5. So that's going to give us 0.192. 0.192. That is tan of theta. So theta now will now be arctan, that is inverse of tan, 0.192. So the final angle for theta is now going to be shift tan of our answer. The shift tan of our answer is going to give us 10.89. So let's approximate it. It's going to give us 10.9 degree. So the 10.9 degree is going to be the direction of the velocity. So the direction, the angle has changed now. Initially the angle was 30 degree. The object is projected at 30 degree to the horizontal, but at 2 seconds after projection, the vertical component and the horizontal component of the body has changed, and now the angle, or which is the direction of projection, has also, or the direction of velocity has also changed to 10.9. So the angle is reducing. Then later it's going to come down, and then before it hits the ground floor again. So that's that about that one. Now let's look at the next example also, which is this one is going to be our final examples, and I would like that you watch this video from the beginning to the end. Alright, let's look at this example. A stone is projected vertically from the ground at an angle of theta to the horizontal. So that's to indicate that it's a vertical projection because it is at an angle theta to the horizontal. So the stone is projected onto the top of a tower of height 100 meter. If the initial velocity of projection is 100 meter per second, they calculate the maximum height above the ground, the time taken to reach the maximum height, the time of flight, and the horizontal distance from the ground to the top of the tower. So let's look at a diagram to illustrate the motion of the ball, so of the stone. So let's say this is the stone, and this is the tower. Let's say this is the tower, and the tower itself is 100 meter high. So this tower is 100 meter high. So let's say this is the tower. So we are told that a ball is projected at an angle of theta to the horizontal to the top of the tower. So let's say the angle of projection here is at angle theta to the horizontal. So now at this case we want to look for the maximum height. We want to look for the maximum height h. Then number 2, we want to look at the time it takes to reach maximum height. So let's just take the parameters now. So for the maximum height, the object moves from here to this point. So for maximum height, our formula is still h equals to u square sine square theta over 2g, because it's a vertical projection at an angle theta to the horizontal. So our u is 30. What's our initial velocity? Okay, if the initial velocity of projection is 100, so the initial velocity is 100, so 100 square sine square of theta, now theta is 30 degree, then over 2. Let's take our gravity to be 10. So it's going to be 100. So we are going to have 10,000 sine square theta. That is, and sine theta is 0.5. So it's 0.5 square. That's the meaning of sine square theta. Then over 20. So what's going to be our h? Our h is going to be whatever this one is. That is 10,000 multiplied by 0.25, because 0.5 square is 0.25. Then divided by 20. So let's find our final result. Our final result is going to be 125 meter. So our maximum height above the ground is 125 meter. So I want you to understand something. So when the object goes up, the total height from the ground, remember this one is just an horizontal, let me trace it down like this. So it means from here, the maximum height to the ground is 125 meter. So definitely, if the top of the tower is 100 meter, it means from here to the top of the tower is just 25 meter. So from here to the top of the tower is just 25 meters, so that everything can be 125. That's for the maximum height. So let's look at the next thing. The next thing is we want to look at the time. So you can copy this side so that I'll be able to clean this side and do the next one. So this is how we solve the number 1 to find the maximum height. So let's find the time of flight as I clean this side. So for the time of flight, the formula for the time of flight is time to reach maximum height is u sine theta over g. So what's going to be our u? Don't forget the one we have just gotten now. That is the maximum height. So let's look at this. U sine theta, and u is initial velocity is 100 sine 30, then over 10. So what's going to be our time? That is 100 multiplied by 0.5 over 10. So our time to reach maximum height is going to be, this one is going to be 50 over 10. It's going to be 5 seconds. So that's our time to reach the maximum height. So the number 3 now, the total time, the time of flight, is talking about the time it uses to go up and it hits here. Now, to find the total time of flight, there's something I need to get to understand. This object goes up, but the object does not land on the ground. If the object goes up and lands on the ground, then the total time of flight is going to be 2t. But if it takes 5 seconds to reach here, it means it's going to take 5 seconds to reach the ground. That is the same horizontal level. But because this object lands on the building, then it means if it takes 5 seconds to reach up here, we must know the time it takes to reach this place. So, and when an object is falling, this is a vertical component, so we are looking for time it takes to reach the top of this tower. And when we know the time to reach the top of this tower, that is when we can now know the total time of flight, whereby we add this first one to the other part of the time. So to now know the time it takes here, so we are going to take this one now. So let me do an illustration here so that you get the concept from this side. So it means the object is coming from here. I want to know what happens to this level. So at this level to this level, the height is 25 meters. And when an object is falling under gravity, we are going to take it as object falling under gravity to know the time it takes for the ball to start from here and hence here. And when an object is falling freely, u is 0. And g is taken as positive because the object is coming down. Then our time is what we are looking for. So if I want to take parameters there, I can say v square. Okay, we are looking for time. If I say v equals to u plus 80, we don't know v. So we are using this formula of h equals to ut plus half gt square. That's the formula we are going to use to find our time t. So to find our time t, so what's our h? The height it takes, the time it takes is what we are looking for, the time from here to the top of the tower. So we are only considering this height 25. So 25 equals to 0 times t. So 25 is going to be 25 multiplied by 0 because u is 0. 0 times t will give me 0. It will only remain gt square. That is g, and g is 10. 10 times t square over 2. So that's what it remains because this one is 0. So let's cross multiply. If I cross multiply, then 50 equals to 10 t square. So divide both sides by 2, by 10. Then it means 5 equals to t square. So let's find our t now. Then t is going to be the square root of 5. So what's the square root of 5? So the square root of 5 is approximated to 2.236. 2.236. So I can approximate it to 2.24 seconds. So the time it takes the body to start from here and come back to this level is t is 2.24 seconds. So let's now look at what is the time of flight of the ball. So the time of flight of the ball, that we are looking for, our t is going to be the time it takes to go here plus the time it takes to come to this level. So the times it takes to reach maximum height, that one is 5 seconds. 5 plus the time it takes to come from here to here. If it comes here to the ground, it will have been 5 seconds also, so that will now be 10. But because it is not to the ground, it is to the height, to the top of a building. So the time from here to here has been calculated to 2.24 seconds. So what is the total time of flight of the building, of the body of the stone? The total time of flight is 7.24 seconds. So we have gotten that one. So you have to understand this concept, and that's why I'm bringing these examples so that you'll be able to get it better. So let's look at the horizontal distance, which is the range. I'm going to clean this one to explain the range. So to find the range, now because if you look at this object, this body, the movement of this body is like a combination of two things. It's a combination of vertical projection, then from here to this point, it looks like horizontal projection. So how do we determine our total range? The formula for our range in this concept, our range is going to be ut. So that's going to be the formula for our range. Our range is going to be ut. But since our u is not a vertical component, range has to do with horizontal component. So our u here will be taken as horizontal component. So our range is going to be, remember, for horizontal component, u is u cos theta. For horizontal component, our u is u cos of theta. So r will now be u cos theta multiplied by t. So that's going to be our range. So what's going to be our u? So our u is 100 and cos 30, because our theta is 30, then multiply by time. What is the time? We are talking about the time before the object lands to the floor, and our time is 7 point, that's the total time, which is 7 point, we have calculated that one, 7.236 seconds, or approximately 7.24. Let's make it 7.24. So our total range is now going to be the multiplication of this. Let's multiply this and multiply everything together like that and get our final result. So our range is 627 meter. So our range is 627 meter. So in this case, we are not going to use the formula of r equals to u squared sine 2 theta over g, because u squared sine 2 theta over g, this formula is only meant for vertical projection. But when we look at this one, though truly it's a vertical projection, but it does not land on the same horizontal level. So from here to here, it's like saying we have an horizontal projection. So there is it's partly horizontal here from here. So we have to split this into two parts and analyze it. So that's why we are using this formula r equals to ut. Now let's do the final examples, which is a case whereby the object is now projected from the top of a building now, if the thing now go in the other direction. So let's look at how we are going to determine all those parameters. So let's take the next example now. So let's look at these final examples, and then we'll end the class with this. A stone is projected from the top of a building 100 meter high at an angle of 30 degrees to the horizontal. If the initial velocity is 100 meter per second, then calculate the maximum height above the ground. Then calculate the time to reach the maximum height, calculate the time of flight, and calculate the horizontal distance from the foot of the tower to point Q on the ground. Now let's look at a diagram to illustrate that projection. So the object is projected from the top of the tower. So let's take this as our tower. So let's take this as the top of the tower. So let's say this is our leveled ground, and the tower itself is 100 meter high. So from here to here is 100 meter. So the tower is 100 meter high. So the body is projected from the top of the tower vertically upward until it lands on the ground level. And is projected at an angle of 30 degrees to the horizontal. So let's take it this way. Let's take this as our horizontal level. So it's at an angle 30 degrees to the horizontal, and the initial velocity of the body is also 100 meter per second. So let's calculate the time taken, the maximum height reached above the ground. Now this one is just, if I want to take the maximum height as far as this formula h equals to u squared sine square theta over 2g. As far as this equation is concerned, this maximum height h you are seeing here is just height from the highest point to the horizontal plane of projection. So this h is the maximum height from the horizontal plane of projection. So this h here is what we are going to get if I use this formula. It's just from here to here. So in order to get the height above the ground, then it means whatever we get as our height h, we add it up to the initial height, which is the height of the tower, which is already 100. So it means from here to the ground level is already noted to be 100 meter. So this one is 100 meters. So we only look for this and we add it up. So let's find our h now. So our h is u squared, that is 100 square sine square of 30 over 2g. So which is going to be 10,000. Then sine 30 is 0.5. And then we square it, then over 20. That is 2 times 10, 20. So if I sum all this one up, it's going to give me 125 meters. So just use your calculator, you're going to get 125 meter. So our h here is 125 meter. So if you are now asked, what is the height above the ground? So definitely the height above the ground in this case, our height above the ground, that is h above ground, is going to be 125 plus 100. That is 125 meter. 125 meter is going to be 125 meter plus 100 plus 100. And if I add it up, it's going to give me 225 meter. So the height of the body above the ground is 225 meter. So let's go to the second one. Then the time to reach the maximum height. So let's look for the time to reach the maximum height. That is the time it takes from here to get to this level. It's also the same thing. So our time to reach the maximum height is also t is u sine theta over g. And our u is still 100 sine 30 then over g, which is 10. So 100 multiplied by 0.5 over 10 is going to be 50 over 10. When you multiply this one, it gives us 50. It's going to be 5 seconds. So our time taken to reach the maximum height is also 5 seconds. Now let's look at the total time of flight. Let's note that one somewhere here. Our time, our T max is 5 seconds. Alright, now let's look at the total time of flight. To know the total time of flight, it means if you take 5 seconds to get to this level, it will take 5 seconds to get to this level, not to the ground level. And since the object from here to here, the object is still in air, is still in flight. The object is still in flight from here, is still in flight because this is the parabolic part, that is the part of the object in flight until it reaches the ground. So if from here to here is 5 seconds, then from here to this place is 5 seconds. So we need to know that time is going to cover from here to this place. So in order to make the work simple, we have to break this thing into two parts. So from here to here is 5 seconds. So let's just treat this one as vertical component. So let's treat the vertical component of time here and know what is going to be our time from this level to the ground level, whereby our height now, our h here, which is total height, is 225 meter. That's our total height. So to the ground is the ground level. So we are going to take our time from here to this level. So we already splitted this one into 2. So from here to here is 5. So from here to the ground, if it is from here to here, it's going to be 5 also. But we want to look at the time that it's going to take to reach to the horizontal level. So at this point, our u will be taken as 0. So if our u is taken as 0, and then we are looking for our time that is going to take for this object to fall from 0, from this height to the ground level, then we are going to say our h equals to ut plus half gt square. So what's our h? Our h is from here to here, which is 225. So 225 equals to ut, and u is 0 times t is 0. So we only have half gt square, that is 10 t square over 2. So that's what we have. So after that, what is going to be, let's cross multiply here. If I cross multiply, so when I cross multiply, this one is going to be 450 equals to 10 t square. So divide both sides by 10. Then t square equals to 45. So t is going to be the square root of 45. And what is going to be the square root of 45? So let's check our calculator. Then the square root of 45 is going to give us 6.7. So the square root of 45 is 6.7 seconds. Approximately, let's just say 6.71 seconds. So it means this body is going to take 5 seconds to reach here, and from here to the ground level is going to be 6.71 seconds. So which means the total time of flight is going to be 5 seconds, that is 5 to reach here, plus 6.71. So the total time of flight is going to be 11.71 seconds. So that's going to be our total time of flight. So if I want to split this thing into 2, it means it takes 5 seconds for the object to reach here. It takes another 5 seconds for the object to get to this level, and it will take that is 1.7, let me say 1.71 seconds for the object to pick from this level to the ground level. So let's look at the last one, which is the horizontal distance covered from this point to point Q. So how do we find our horizontal distance, which is our range? Remember, range is supposed to be r equals to u square sine 2 theta over g. But because we are dealing with this projection is from here, and it does not stop at this same horizontal level. It landed here. So it's just like the previous example we did. So in order to find range, in this case, our formula is going to be r equals to ut, whereby our u is going to be the horizontal component of the velocity. So whereby your ux is going to be u cos of theta. So that's the formula we are going to use. So let's find our range now. So substituting r, then r is going to be ut. So u cos theta multiplied by t. So what's our u? Initial velocity is 100 multiplied by what is cos theta, and theta is 30 cos theta, and multiplied by t. What is the t? That is the total time, the time it takes for the object to reach to the ground, which is 11.71. So if I multiply everything together like that, we are going to get our final range. So when we multiply everything together, it's going to give us 1014.12 meter. So this is going to be our range. So anytime we are given projections of this form, this is how we find our range. R is going to be u cos theta multiplied by t. But if you are given, if the thing lands on the same horizontal level as the previous examples, so we can then use r equals to u square sine 2 theta over g. Thank you for watching this video. As far as this class is concerned, this is going to be the end of. So as far as this class is concerned, this is going to be the end of this class. Thank you for watching this video. Make sure you watch the projectile 1, 2, and 3 to get the full concept of the topic projectile. Make sure you subscribe to this video and send this video, share it to your friend, share it to anybody. Just begin to share, just share it and let people like this video. Then comment in the comment section. If you have any questions, you can just drop your question. Thank you and God bless you.